Okay, let's finish this session by looking into some international and some of the department's research activities. As aforementioned, the predominant trends are simplification, collaboration, and digitalization. Let's have a look at the video by the Wandelbots when it comes to simplification. As aforementioned, one of the difficulties is the programming of the industrial manipulators. And this in itself shows a very nice simplification of robot programming, though I think we should keep in mind that the displayed application can only be realized on calibrated industrial manipulators, because this kind of teaching that is displayed in this video does rely on the accuracy of the robot rather than the repeatability of the industrial robot, as it isn't taught the configurations that it is supposed to reach. Then there's the topic of collaboration. For this, we can have a look into one of the implemented case studies of the ABB's you-me, which is short for you and me, implying a collaborative task. Here you can see how a worker and a robot engage in responsive collaboration. Then these last two videos are essentially the same. They feature the topic of digitalization. It shows how Ford in the United States uses drones, which are also a kind of robot, in order to scan their facilities. So, those are examples of international research. Then, there is research that the department does engage in. This is the project overview of the Coroma project, which finished in 2018 and the department was engaged in. And it shows you the idea of autonomous collaboration of industrial robots and workers on the shop floor, while at the same time being able to perform a multitude of tasks, ranging from inspection to machining tasks. As we are of course unable to develop such a system all on our own, the question is, so what is the contribution of this department when it comes to the Coroma project? And the best thing that we can do is to show you what some of the members of the department do. And there's the research being conducted by the Precision Engineering and Metrology group. And here you can see an example on how experimental modal analysis is used in order to validate simulations of an industrial manipulator. On the left-hand side, you see a visualization being derived from the modal analysis, and on the right-hand side, you see the simulation of the corresponding manipulator. And that is one of the things that we have contributed to the Coroma project. And if you're interested to know more about this mechanics-based analysis of the system in itself, feel free to contact the people outlined on this slide. And then there's another group in this department that has done a contribution to the Coroma project, and that is the multimodal operation of industrial manipulators. And here you can see how one of our colleagues speaks into the microphone in order to give voice tasks or voice-based tasks to the industrial manipulator in order to move into a certain direction. And he also uses the leap motion sensor in order to engage with... here we go. Here he uses the leap motion sensor in order to give an additional set of instructions to the robot. Unfortunately, I'm not allowed to share those last videos with you. So if you're interested in getting more information about these, feel free to contact me in any time. Or feel free to directly contact our colleague Xiao. Thank you very much for your attention. This finalizes the presentation on industrial manipulator in manufacturing processes, and I would like to repeat that the intended learning outcomes of this lecture were to understand the requirements and similarities between established application fields of industrial robotics in manufacturing processes, describing the configurations and working principles of industrial robots, being able to assess and justify how different designs of industrial manipulators influence their performance, and identifying and preventing risks associated with the operation of industrial manipulators and robotic cells. Please feel free to contact me in case of questions. Thank you very much.